Expanding two brackets. What am I doing? I'm multiplying. Okay, so let's look at our first example here. Okay, so my first example, I'm going to look at expanding, which means multiplying n plus 3 times n plus 5. Okay, and the method that we're going to use here is called the FOIL method. It's used all the time. FOIL is F-O-I-L. Okay, and the F stands for first, the O stands for outside, the I stands for inside, and L stands for last. It's pretty appropriate leaving L for last. What these means is I'm going to multiply the first two terms, and then I'm going to multiply the outside terms, and then the inside terms, and then the last terms. What? So let's focus on the first. Here are the first two terms, and I'm just going to put an arrow there. Okay, n times n. N times n is n squared. And then, expanding only has to do with multiplying, and then I'm going to multiply the outside terms. Okay, what are the outside terms? Right here, and I'll show that with arrows there. Those are my outside terms, and n times 5 is positive 5n. And then what I'm looking at are the inside terms. Well, the inside terms are the ones that are close together. That's right there. And 3 times n is positive 3n. And lastly, of course, we do the last terms, which is 3 times 5. And 3 times 5 is positive 15. Okay, now what we're going to have in these problems is sometimes, not always, but usually, these middle two terms we can collect. So we're going to collect like terms right here if we can, because 5n and 3n are like terms. Okay, so when I do that, the n squared is still by itself. 5n plus 3n gives me 8n, and the positive 15 is still by itself as well. And right here, I have my expression for when I multiply these two brackets together. And I can't do anything more than that because these guys are not like terms. I can't add them together and make 9n squared or anything like that. It's finished. Okay, let's look at our next example, and we just do the same thing. First, outside, inside, last. So first terms we're going to multiply, and the product of the first two terms is x squared. And now for the outside, that's x times 7. That's positive 7x. Inside terms are going to be negative 3 times x, which gives me negative 3x. And finally, it's going to be negative 3 times 7, which is the last. And that gives me minus 21. Collecting like terms here, they're always going to be the middle two for this lesson. And 7x take away 3x is 4x. Okay, now let's look at something. What I want us to look at here is I want us to look at kind of this coefficient right there, that 4, and also that negative 21. And how it works out is you say, okay, well, how do these numbers relate to these numbers down here? How does a negative 3 and a positive 7 relate to this positive 4 and negative 21? And how it will always work out with problems like this is that 4 will be the sum of those two. Negative 3 plus 7, that's 4. And this number will always be the product of those two. Negative 3 times 7 will give me that negative 21. And that'll always be the case as long as there isn't anything in front of those x's. So let's try another example, keeping this in mind, and that's kind of a good way to check it. Okay, so that coefficient's the sum of these numbers, and this number is the product. Okay, now I've got to include this example because this is a 2-bracket one in disguise. M plus 6 squared does not mean m squared plus 6 squared. All right, exponents are repeated multiplication. So what it means is this. And that's what most people trip up on, is they forget that there's 2 brackets wedged in there, like exponents, just like 3 squared equals 3 times 3. No different. And now we do the first, outside, inside, last. And I'm not going to do the arrows this time because that might be too confusing and I don't have enough room. First is m squared. Outside is positive 6m. Inside is another positive 6m. And the last is 36. Remember, each time we do that, we're multiplying. Now we collect like terms, which will be in the middle. 6m plus 6m is 12m. And we can check that trick I did over there. Yep, 6 plus 6 equals 12, and 6 times 6 equals 36. So that works the same here as it did over there. Okay? Okay, let's look at a couple more examples, and then we'll be good. Okay, guys, let's go. One more. Same thing here, but something different happened. So first, p squared outside, 7p inside, negative 7p, and the last, negative 7 times 7 is negative 49. And what happens here, when I combine these two terms here, 7p plus 7p minus 7p turns to 0. So that middle term gets canceled out, and I'm just left with an expression that has no middle term, just p squared minus 49. Yeah. That's just the method that we use. It's kind of like BEDMAS. It's an acronym. Yep. Cool. Thank you. Okay. So for that, we don't need to write plus 0p or anything because 0 is 0. All right. Now let's do one more more of a difficult example. Okay, so this one's different in that I have a coefficient in front of the n this time, but same thing applies. First, 2n times n is 2n squared. Outside, 2n times negative 7 is minus 14n. Inside, 3 times n is positive 3n. And last, 3 times negative 7 is minus 21. So just kind of first, outside, inside, last. When I do that thing, that FOIL thing, it's just multiplying. So when we do that 3 times negative 7, it's not going to be minus 4 or anything, it's multiplying. And finally, negative 14 plus 13 combined to get me negative 11. So I write it as 2n squared minus 11n minus 21 for my final answer, and I don't collect any like terms there because I don't have any. Okay, so I'll put some examples up here for us to try and see how we do. All right, try some of these. Pause it and see how you do.